Hello and welcome. Today I would like to talk about solder. Here I have a lot of different rolls of solder, some of which I bought a longer time ago, some I bought recently, and also got some as a donation from a viewer. So let's see what I have here and if anything of that is actually good. For a longer time I had a roll of 0.8mm leaded solder which was manufactured in Germany. And that was really nice to work with. Unfortunately, just as anything, also that roll came to its end one day and I had to buy something new. It is much easier to work with leaded solder because it has a much lower melting point and also better flow capabilities, at least what I can tell from my experience. Unfortunately, lead is poisonous and was mostly banned everywhere. It turned out that meanwhile it became hard to buy good leaded solder, and most of the stuff you get in good quality is lead-free. Like this green roll. I gave it a try for a while and though it wasn't bad, it still was much worse than to work with the good old leaded solder. As you see, this solder is made of 99.3% tin and 0.7% copper, which is marked as lead for some reason, but well. That so-called tin-copper alloy mixed with flux is what makes a solder wire. Flux is very important, but to be honest, I don't quite understand how that counts. 99.3% tin plus 0.7% copper makes already 100%, so where do those up to 3% flux go into? Maybe alloy makes 97% of the wire and flux the other 3%? Well, if you know how it counts, please enlighten me in the comments. Anyway, I use this solder a lot and it is not bad, but needs about 250 degrees Celsius to melt and is really usable first at around 350 degrees Celsius. What is a quite high temperature, especially when you solder old and hard to find chips. So I looked around and found this leaded solder from the same manufacturer, Z, and decided to try that. As you see, this one has 63% tin and 37% lead. Basically, I was hoping to get the same quality, but with the lower melting temperature. It didn't work all that well, unfortunately. The quality of the leaded solder was awful. It did melt at a lower temperature, mostly, but was inconsistent over the length of the wire. And sometimes it worked well, sometimes it was crumbly and didn't stick to the solder joints properly, so I needed to raise the temperature again to be able to work with. For a couple of centimeters it was fine, then the temperature was too high again and the solder burned, so I had to lower the temperature again. That was very annoying, so I often switched to the lead-free solder again. However, I didn't lose the hope and followed the advices on some forums, where these two guys were suggested as a good enough quality solder. The Kana on the left and the Classical Mechanic on the right. Both have 37% lead and promise to have a good and constant flow. Unfortunately, as I ordered these rolls of solder, I probably misclicked in the selection field and ordered the wrong size. You see, this one is 0.6mm. I like to work with wires between 0.5 and 0.8mm because you can better control the amount of solder you get on the tip of the soldering iron. As you see, my other rolls are also 0.6mm in diameter. Well, unfortunately, this one is 1.5mm and is very thick. It's going to be hard to solder small SMD parts with it. Here you can compare the diameters of the wires. The 1.5mm look huge compared to the 0.6mm. The problem is that when you want to tin the traces or solder just one pin of an SMD chip, you want to have a drop of solder on the tip of the iron, which is just as little as possible. If the wire is too thick, you always get a huge blob of solder instantly as soon as you touch the wire. Then you have problems to clean up the mess again, and anyway, it's annoying. If you mostly work with microelectronics and don't solder huge connectors all the time, then try to get thinner solder wire. Diameter of 0.5mm is a good size. Well, after I bought those rolls of solder, a viewer of my channel, which already made a lot of mind-blowing donations, have sent me a couple of old rolls of leaded solder too. Here you can see SN60 PB40 written on the roll, which means tin 60% and lead 40%. I already tried this solder and it is very good, probably like the one which I had previously. Unfortunately, also here the wire is a bit too thick for my taste, probably 1 millimeter or so, but still I'm happy to have this roll. And as it was not enough, in addition to the blue roll I got these two guys. These are also made of leaded alloy, but have even 2 millimeters in diameter. This one seems to have 60% tin, 38% lead and 2% copper, which is unusual. What I can tell from this one, it smells terrible when melting, but I don't think that I will use it a lot, only to solder bigger connectors or so. For soldering of small parts, it is just a bit too clunky. Now let's test and compare those solders. I usually solder at around 280 to 300 degrees Celsius. At that temperature, usually even lead-free solder starts to be usable. For a good leaded solder, around 250 degrees Celsius would be more than sufficient. But at 300 degrees Celsius, all of these should flow fine. Yeah, as you see, the tip is very small and this thick solder wire acts as a heat spreader, so the solder doesn't melt instantly. With thinner wires, this will not happen. And I will not test those 2 millimeter solder wires anyway. As I said, that is good to solder bigger parts like connectors, what doesn't happen all that often, so today I will limit my test to thinner wires only. Okay, first of all, let's find out how honest the markings on the rolls are. Solder with 37% lead or more should start to melt at around 185 degrees Celsius, and at 200 degrees Celsius it should already flow very well. First, I will start with this old blue roll of leaded solder, which I got donated. It has handwritten 40% lead label on it. Let's see. And yes, at 200 degrees Celsius it melts just fine. The solder is shiny, consistent and completely fluid. Though, to be honest, this one smells terrible when melting, but that's another story. Now let's check the leaded solder which I bought and which I was not happy with. This one tells 37% lead and should melt at 200 degrees Celsius just as good. And as you see, it doesn't melt so well. Even where the wires is half as thick as the previous one, it struggles to melt. It's uneven and clumpy, and this is what I meant. This solder melts sometimes nicely at 250 degrees Celsius, but then there are parts of it which don't melt properly even at 300 degrees. That makes soldering SMD parts or reflowing solder on chips nearly impossible. Okay, next solder is lead-free. Just to show the difference, lead-free solder should start to melt at around 230 degrees Celsius, but really usable it is first at around 300 degrees. And as you see, at 200 degrees Celsius it doesn't even think to melt. If you look closely you can see the flux melting, but the alloy itself remains completely solid. Okay, the next one is again leaded solder with 37% lead. This one should melt fine. This solder was highly recommended in multiple electronics forums, so I have high hopes in it. A funny anecdote about this one, I ordered it on AliExpress and as it arrived, I put it aside until I have time to test it. After a couple of days I got a warning mail from AliExpress that this solder contains dangerous chemicals, in particular lead. It has been called illegal and I should send it back or throw away. Who would think that in leaded solder there is lead? Well, at least the shop where I bought it doesn't sell it anymore, but there are others who still have it in the list. And as you see, this solder is really nice indeed. It melts evenly and looks very good so far. So the next one is this Kana leaded solder, which was also recommended by many tinkerers. As I said, unfortunately I bought the wrong wire and this one is too thick, but let's still see how it goes. Oh, wow, this one looks really good too. As you see, it is hard to place a small blob of solder onto the tip with a wire of this thickness. But the solder melts nicely and looks very clean. As I said, these thicker wires I will not test today. They are just too thick for delicate work, but I will definitely use those in other cases. Okay, now let's set the soldering iron to 300 degrees and see how the solder behaves when actually being soldered. Once again, let's start with the blue roll. Well, looks good so far. The solder applies mostly evenly and remains shiny after it is cooled down. Now the leaded Lu Shangzi solder. And again, do you see how uneven it applies? The soldering iron is set to 300 degrees and the solder seems not to flow properly. It looks more like a gel than fluid when it's hot. Yeah, and when it cools down, you even can see that this surface is not consistent. It has to be completely shiny without those stripes. Next one is the lead-free Lu Shangzi solder. Also, this one seems to be still a little bit clumpy, but otherwise it applies evenly. From my feeling, I would say that soldering with this lead-free solder is easier than with the previous roll of bad leaded solder. And as you see, the typical dull surface of the lead-free solder when it cools down. Leaded solder remains shiny and lead-free solder gets dull when it cools down. But it looks quite even though, and is not bad result for a lead-free solder. Next one is the Mechanic HX T100. This one melts very well, but it cooled down with that imperfection stripe, which is not nice. Let me try to give it a second chance. Still there. It can be a sign of impureness in the alloy. Maybe also something on the tip, although I clean it after every try. At least this solder flows very well. Next one is leaded solder from Kana. It flows nicely, but somehow it cools down unevenly. Let me better clean the tip once again. Yeah, much better now. Though I don't know if we can compare that. The wire is thicker, so I give a lot more solder onto the pad compared to the other solders. Anyway, the result looks really good. So, what do I think? First, let's put the thicker wires aside. As I said, they are not interesting for fine repairs, and since they are old and origin is not known, they can't be bought anymore and are not interesting anyway. And talking of old, this blue roll of solder seems to be the best, but also this one cannot be bought, so let's put it aside as well. However, this is how a good solder should be. So we are left with these 4 rolls which are obtainable. Let's start from worst to the best. As I said, this lead-free solder is not bad, but you need high temperatures and it is much easier to work with leaded solder if you find good one. And this leaded solder is bad. It is so bad that it is even harder to use than the lead-free version. So the least one I would suggest is this leaded Lu Shangzi solder. It is terribly inconsistent and it is very hard to work with. Instead, you should take this lead-free solder from the same manufacturer. You will need to work at high temperatures, but at least it is of much better quality and consistent over the length of the wire. These two are now hard to order. From my feeling, the solder from Kana was the better option. However, the wire diameter which I accidentally ordered was twice as thick, and so I get more solder on the tip, which can result in a better flow. Off camera, I tested both of these on some real repair cases. Both are not bad, but I would say that Mechanic HXT100 had more impurities, so I would say that the roll from Kana gave me the best results. I think in the future I will mostly use this blue roll or the one from Kana for delicate work. Of course, I will not throw anything away and will use all of this dependent on the use case. For bigger solder joints, all of those solders are okay, but for SMD parts as well as old and rare chips, I will prefer something what I can use with lower temperatures. Yeah, and I'm glad to say that I should now have enough solder for years and hopefully many videos. And if you want to see this solder in action, consider to check out my channel from time to time. Thank you for watching and goodbye.